name is Sweta, and this is my final presentation for Info 5810 Data Analysis and Knowledge Discovery. I will be doing a walkthrough of my dataset, review my Jupyter Notebook file, and provide a conclusion of things that I learned while working on this project. So with that, let's get started. The dataset that I used, it's called stores, and as you can see, the dataset provides the store ID, the area, the items available, daily customer count, and store sales for 8,967 different stores. In a business context, the purpose of dissecting this data is to investigate if certain factors such as the area of the store or the daily customer count, etc., can ultimately increase store sales. Analyzing this data set and running prediction models can be valuable for store owners who utilize these findings to boost their store sales. So now that we have some background information on the file itself, let's look into the Jupyter Notebook that I created. So the first thing I did here was convert my data set into a pandas data frame and use the head function to show the first 5 rows of my data set just to confirm that it was displayed correctly. In this case, everything looks great. Down here, you can see that I split the data set into training and testing sets. I dropped the field store sales as I decided this will be my dependent variable. I chose to keep the rest of the fields as features because each field, such as the store area, available items, etc., can be a factor that affects the dependent variable, or in this case, store sales. Moving forward, I decided to conduct a more thorough analysis of the data set just to get more information about it and understand if the data needs to be cleaned. It's important that basic analysis is done to the data set to see if there are any inconsistencies that need to be filtered out. Over here, I found that there are observations in the data set with null values, no null values. I also found out that there are no features in the data set with no entries. Moving along, I used the unique function to ensure that there were no constant values reoccurring in the training data set. The output shows that there are no constant values nor quasi-constant values. I also checked to make sure that there was no rows that were duplicated in the dataset. Because there are no rows listed over here, it is expected that there were no duplicated values in the dataset. I also confirmed over here that there are no missing values in general. Starting over here is when I started a good chunk of the exploratory analysis of my dataset. I was mainly attempting to find patterns within the data and test my hypothesis that certain features correlate to the increase of store sales. I first used a describe function to get a general understanding of the data that I'm working with. The shape function also provided me with basic information that there is 896 rows and 5 columns. Just to double check that there are no null values in the dataset, I used the isNull function. You can see in this area that there are no null values in this dataset. Up until here, I can see that the data in my dataset is already prepared. With this in mind, moving forward, I wanted to check out any trends that could possibly be explored in the data itself. I first decided to explore the trends in daily customer count. By plotting this histogram, I can see that about 200 stores have an average of about 750 customers at their store. The minimum number of customers at a store is 0, and the maximum is about 1,500. In a business standpoint, information like this can provide store owners with a good indication of the range of customers coming into a store. Store owners should aim to maintain an average of at least 750 customers because this is the number of customers that are coming to the majority of stores in the dataset. Moving along, I decided to start the process of creating a heat map using the core function right over here. I decided to take out the store ID column because it's a feature that will not have any correlations. And you can see that right over here. In the heat map specifically, you can see that the light green color shows a major correlation and black represents almost no correlation at all. Judging by this heat map, you can see that there is a correlation between store area and items available, whereas there's not a good correlation between daily customer count and available items or store area. To further prove the point that there is a high correlation between store area and items available, I decided to use a series of functions to help identify the highest multi-collinearity. The high VIF values that are found over here indicate that store area and items available have the highest VIF values and therefore are highly correlated. At this point, I feel like I have a good understanding of my data set and can move towards a predictive modeling. Moving forward, I decided not to use classification modeling because my data set is continuous with a continuous dependent variable. Over here, I use the linear regression library to show the prediction of a new row in a data set. This describes prediction of each field and prediction of store sales, which is about 47,268. Moving forward, I use the prediction function to display predicted amounts of a test set based off the information of the current data set. In total, the test set should be about 25% of the total 896 rows. It's quite a bit. To test the error in my predictions, I use the mean squared error library. As you can see, I seem to be off about 16,000, which is quite a bit. I'll continue to test and compare my errors as we continue the project. Next, I wanted to test out predictions on specific fields. Here, I decided trying to omit all fields except for items available and store area to see if this would affect the total store sales. You can see that the output has about $51,081 store sales and subtracts about $4 per item available and adding about $10 per square foot of area. Finally, this prediction model checks to see if if omitting extra fields lowers the standard error. By comparing this value to the one above, you can see that the standard error was in fact slightly lowered. And for the most part, this wraps up the presentation of my Jupyter Notebook file. I wanted to touch on a few items I learned during the duration of this project. By breaking down my data set, I would say there was definitely a correlation between the values of store area and items available that affect the sales of a store. By looking at prediction model, it is clear that the more square footage of a store, the more probable it is to have a higher store sale. From a business standpoint, understanding predictions like these can be immensely beneficial for store owners, as they can modify their store attributes to boost the amount of sales they bring in. Overall, my initial hypothesis was correct in that certain fields within the data set can have the power to boost or lower store sales. And that is the conclusion of my project. Thank you so much for listening.